Welcome everyone. Let's discuss another question from GATE 2022 Life Sciences. The question is, the half maximal velocity of an enzyme catalyzed reaction was found at a substrate concentration of 0.5 into 10 raised to power minus 6 molar. This enzyme follows Michaelis-Menten kinetics. In the presence of a competitive inhibitor, the half maximal velocity was found at a substrate concentration of 1.5 into 10 raised to power minus 6 molar. Given that the enzyme inhibitor pair has a dissociation constant of 2 into 10 raised to power minus 7 molar, you need to find the concentration of the competitive inhibitor in micromolar, and the value has to be round up to one place of decimal. Let's try to decode this question. What all is given in this question? This question discusses about the competitive inhibitor, and the values are given both in the absence as well as in the presence of competitive inhibitor. The half Vmax value is given, and we all know what do you mean by half Vmax? Half Vmax is also defined as the Km. So Km is the substrate concentration at which the rate of the reaction is half of its maximal velocity. And the Km in the absence of the inhibitor, the value given is 0.5 into 10 raised to power minus 6 molar Km in the absence of inhibitor. Now Km in the presence of the inhibitor, the value of the Km in the presence of the inhibitor given is 1.5 into 10 raised to power minus 6 molar. Now one thing we need to understand, in case of the competitive inhibitor, if you look at the Michaelis-Menten equation, which is initial reaction velocity is Vmax S Km plus S, and the same equation in the presence of the competitive inhibitor becomes Vmax S. The value of the Km changes by alpha factor, and that's the reason I'm representing the Km by alpha Km plus S. Now we need to understand one thing is, in the presence of the inhibitor, both the substrate as well as the inhibitor competes for the enzyme's active site, and that results in the decrease in the affinity between the enzyme and substrate. That results in the increase in the Km value, which makes sense because Km also describes the affinity between the enzyme and the substrate. The lower the value of Km, the higher the affinity between the enzyme and the substrate. However, the Vmax remains unchanged in the presence of the inhibitor. The reason being, remember in our previous discussion, I said you can overcome such situation by increasing the concentration of the substrate to a higher value. So what I'm trying to tell you is you can still achieve Vmax even in the presence of the competitive inhibitor by increasing the concentration of a substrate. You can keep on increasing the substrate concentration to a very higher value, and you will be able to achieve the Vmax. So there is no effect on the Vmax, and that is the peculiarity of the competitive inhibition. So the Km is increased and the Vmax remains unchanged. So talking again about this question is, the values of the Kms are given, and as I said, the in presence of the inhibitor, the Km becomes the apparent Km. So you can represent it by Km dash or apparent Km, which is equal to alpha Km. That means the initial Km value is increased by the alpha factor. So with the help of this, you can calculate the value of alpha, which is alpha equal to Km apparent or dash by Km. Now remember, Km dash is 1.5 into 10 raised to power minus 6 molar, and then you have Km in the absence of inhibitor, presence of inhibitor, and then this is the value of absence of inhibitor, and this value given, the denominator is 0.5 into 10 raised to power minus 6 molar, and you'll get a value of 3. Now, why I'm calculating all these? Because The question, in this question, we have to calculate the concentration of the competitive inhibitor. And if you'll further, elaborate this alpha value, alpha term, you can rewrite it as a alpha equal to 1 plus I by Ki. And Ki is the dissociation constant for the enzyme inhibitor complex. And this value is given. And the concentration of the I you have to calculate. So alpha 3, which we have already calculated, 1 plus concentration of I need to calculate. And the value of dissociation constant is given, which is 2 into 10 raised to the minus 7 molar. So we can solve this equation. I'll rewrite it. 3 equals to 1 plus I by concentration of the inhibitor 2 into 10 raised to the minus 7 molar. Remember, we need to report our answer in micromolars and in a decimal up to 1 decimal point. So I can rewrite this as a 3 minus 1 equal to I concentration of the inhibitor 2 into 10 raised to the minus 7 molar. Simple calculation, concentration of I is going to be 3 minus 1, 2 into 2, 4 into 10 raised to the minus 7 molar, but we need to report it in micromolar, which is a simple conversion. 4 into 10 raised to the minus 7 molar. 1 molar equals to 10 raised to the 6 micromolar, and this value will become 4 into 10 raised to the minus 1 micromolar. Again, we need to be very careful because they have asked in a decimal. So this will get converted into 4 divided by 10, which is 0.4 micromolar is the final answer. So if we'll go back and can read that question, the concentration of the competitive inhibitor in micromolar rounded off to one place of decimal was, this value is going to be 0.4. I hope this solution is clear to each and every one of you. If not, please let me know in the comment section. Thank you for watching the video.